This episode of the Fire Alarm Insider is proudly brought to you by Secured Securities, your trusted partner in fire alarm and security solutions, protecting lives and businesses one system at a time. If you understand these 5 parts, then you can understand any fire alarm system. A fire alarm is a very simple design until someone complicates it. So in today's episode, we're going to do just the opposite. We're going to simplify how you can understand a fire alarm system, and we're going to break it down to the LMNOP. While you're working on a studio apartment, a school, warehouse, skyscraper, every fire alarm system comes down to 5 major components. And if you lock these in, you clear up all of the confusion. So we're going to start with the control panel. We're going to call this the brain. At the top of this, I want you to think of the fire alarm control panel as the brain of the system. So here's what it does in plain English. It receives a signal from a device in the field. It processes that information and then makes a decision. It activates an output like the horns, the strobes, or any particular relay connected to it, and it communicates with the central station that is off-site, sending that same exact signal over. So if they have to send the fire department there or just send you an email, text, call, whatever to let you know that something is going on with your fire alarm system. So absolutely nothing happens in the system without the CPU knowing and displaying it on the front display panel. If the device activates, then the panel decides if this is an alarm, if this is a trouble or a supervisory condition. From that point, it will output the events. So if you understand that the panel and you understand that the system thinks, then you can understand what the initiating devices are. These are like the senses of the panel. If the panel is the brain, then the initiating devices are the senses. This is going to tell you what's happening outside in the field. So these are the devices that detect an emergency, whether it be automatic or manual operation. And some examples include smoke detectors, heat detectors, manual pull stations, water flows, and tamper switches. Their only job is to detect a condition and report it. They don't make decisions. They don't notify the occupants. They simply say something's happening here, and that's it. This episode of the Fire Alarm Insider is sponsored by the Fire Alarm Business Blueprint. If you're a seasoned technician looking to start your own fire alarm business, we have a 9-step course for you to take you from starting your business to getting your fire alarm license, marketing, and also getting money into your business. If this sounds like you, the link is in the show notes. And let's get back to the program. So if this breakdown is making things click for you, I want you to subscribe to this podcast. Every episode is designed to make this complex simple, and usable. And if you're a new technician who's still trying to see the whole entire picture, I want you to share this episode with them to help them out in their journey to becoming a better fire alarm technician. All right, so let's keep it moving. Next, we have the notification appliances. This is like the voice or the enunciation of the system. Some examples are horns and horn strobes, which are combination devices, and then they have strobe-only devices, and then they have speakers and speaker strobes. Detection means nothing if people don't know what's going on. Life safety relies on communication. The system must alert occupants, be loud enough, be visible enough, and be clear enough that you can hear the words that are coming out of the speakers. A fire alarm that detects danger but doesn't communicate is useless. Next, we're going to move into circuits and wirings. I want you to think of this like the nervous system of this entire fire alarm system. You'll hear terms like SLC, which is the signaling line circuit, or the data circuit, NAC, which is the notification appliance circuit. This is what feeds the horns, strobes, and speaker strobes. And you also hear IDC, which is your indicating device circuit. These are the circuits that you will probably hear, or the terms and acronyms that you'll hear throughout the field of the fire alarm. So here's the simple truth. The wiring is how the brain speaks to the body. The SLC is your data loop. This is how your input devices or your output devices communicate over the fire alarm wires to the CPU to let them know that there's a condition, alarm, trouble, supervisory, whatever the condition is. This will report the condition over those wires to the CPU so the CPU can display it and then turn on the NACs, which is your notification appliance circuits. These are your outputs. It could be connected to relays to shut down fans. It could be connected to your horns and strobes to activate the temporal 3, or it could be activated from your speakers connected to amplifiers, so that way you can send voice messages over the fire alarm wires. And then you have IDC. These are the devices that actually sit on a SLC loop. So more so this term will be used in a zone type system, but think of your IDC as all of your input and output modules. These are your indicating. So I want you to think of your IDC as all of your initiating devices. So anything that will initiate an alarm is your IDC. So that will also be on the SLC loop, talking back and forth. So if the wiring is compromised, then your whole system is as well. Always keep in mind, when you troubleshooting, you don't just pick random spots and think that you're going to fix the problem. You must follow the path of communication. Sometimes you may have to go device to device until you can build that map inside your head before you can start jumping over other devices. But follow the path of communication. You'll always fix any problem when it comes to fire alarm systems. Next, we're going to move over to power supplies and batteries. This is like the heartbeat of the system. The fire alarm system must work if everything else fails. This is what the code requires: a primary power source, which is 120 volts, and a secondary power source, which is your backup batteries. They have to be 12 volts, 2 batteries. In series, make it 24 volts. It could be anywhere from 7 amp hour batteries all the way up, depending on the size of your system. If it's drawing a lot of power, you want to make sure you have backup batteries that could support that power. So standby requirements is anywhere between 24 hours of standby time, 5 minutes of full alarm operation, or 15 minutes in full alarm operation. Depending on if you have a voice system or not, you will have to test this operation to make sure the batteries can hold up if there's no AC power. So if the heartbeat stops, that means the system is completely dead. Even if your components is perfect, if there's no power to your system, then the system is absolutely useless in the field. So here's the takeaway. When you understand the system and you can actually start building the map inside of your mind of how this system is potentially wired, troubleshooting becomes easy. You're no longer guessing, and you're no longer intimidated by whatever system you're working on. Siemens, Edwards, Notifier, Gamewell, it doesn't matter the system. You'll be able to quickly figure out any problems if you follow the path of communication. So I want you to start thinking like the system and not like the parts. This episode of the Fire Alarm Insight is brought to you by Secured Security. Secured Securities presents you the perfect fire alarm install, from inception all the way down to installation to the one-time pass inspection with the fire department. If you're looking for the perfect install, click the link in the show notes to talk more. So if you got any value from this episode, I want you to do 2 things. Subscribe for more simple breakdowns of this complex fire alarm system, and share this episode with someone who's actually learning the trade. The more clear we explain, the stronger the industry become. We all become experts, and we all can make more money in this field. So your voice is the bridge between confusion and understanding. I'm the fire alarm expert, and I'll catch you in the next episode. Peace.